Let me guess. You just started using Godot, and you made your game, and you made level 1, and then you made level 2, and you said, okay, scene 1, scene 2, how do I get to the second level after I beat the first level? And then you went in and you found a nice little handy function called change scene. And then you beat the level, and then you have your code that says when you beat the level, then you change scenes. And then, oh no, my character's gone, the HP's gone, everything I worked so hard for. How do I get my character to go from one scene to another scene? And then you try to do an auto load, and then you're passing your data all over the place. It doesn't have to be that hard, man. It's not that hard. It's not that hard, but nobody told you, and I'm going to tell you. I'm going to tell you how to do it. The easy way, the better way. I got you. I got you. Don't worry. All right. Game is very simple. I don't think you could even call this a game. We have a main menu. We have 2 levels. We have a character. He has HP. Ooh, ooh, ooh. You can take damage when I hit space. You can enter the door, and you can go to the new level, and as you can see, he still has 78 HP. You can go back to level 1. Although you will see he stays in the same place. That's a improvement that could be made, is putting him somewhere else. But then we go back. You enter the quit door, and you go back to the main menu. Very simple. Before we get too far in, I want to tell you something about myself. I am a why guy. I'm not a how guy. I'm not going to just tell you how. Maybe I'll tell you how. Maybe if I'm feeling generous, I'll tell you how. But I'm going to tell you why. And then I'm going to hope that if you know why, you can tell how for yourself. Right? If you knew why, you wouldn't have clicked on this video. So now you got to know why. You're going to know why. All right? All right, good. Glad we got that out of the way. So to understand what's going on, you're going to have to understand the scene tree. This is a core concept of Godot. Don't think about the scene tree as a tree of scenes. Think about it as a scene with a tree in it. The tree is a tree of nodes. So when you start the game, you can view the scene tree by clicking in this remote tab over here. This has all the nodes that are currently instanced. From the start, we are starting with a scene I have defined under project settings run, right? So I have my main scene here. The main scene has the main menu scene in it. I instanced the main menu scene in the main scene. So at the start of the game, it's going to have my main scene and an instance of the main menu scene too. It also has the screen fader, which is an auto load. So any auto loads you define here, it's just, what it does is it just instances them at the same level as your main scene. And they're going to be sticking up here at the top level. They also get turned into classes that you can reference anywhere in your whole project. So by the name here that you define, this makes this node with this script available in global scope. But it's just the same thing as if you had instanced title. Like, it's still a node that exists in the scene tree. It's just that you can reference it everywhere. And it doesn't get cleared out if you use the change scene method, which we'll talk about. So that's how you look at the scene tree. Then when you're playing the game, as you instance scenes and nodes and objects, the scene tree changes. And that's how you go from levels to levels and create enemies and all that. This is really important to understanding how Godot works. So I think it's important to understand that when you're running scenes, you might be confused by this little button up here, play scene. Running scenes in the game isn't the same as running them in the engine. Like, when you do change scene, what happens is it clears out whatever you have in here minus auto loads, and it replaces the whole thing with the new scene. So like, when you have small games, using change scene is fine, because maybe you only care about, like, I only care about this level, and then I only care about this level. But if you have anything that you want to keep around, you don't want to clear the entire scene tree. You want to have some nodes sticking around, and you don't want them to be available everywhere like an auto load or running all the time. You just want them to be around for a while, right? Like, I don't want my player to exist when I'm in the menus or when I'm in the credits. You know, I don't need the player around at that point. I don't want them like taking damage accidentally, or like, you know, they can go at that point, but I do want them around while I'm playing the game. So I don't want to be change scene. I don't want to be using change scene while I'm in the game. So in object-oriented languages, there's a concept called classes and objects. Classes are definitions. Objects are instances. You have one class called one thing, level, and then you have instances of the level that each have something in them. You have an instance, you have a class called enemy. You have object, enemy objects. You can have 100 enemy objects, right? All the enemies have the same data in them. The instances might be different. They might have different HP values, but they're all the same thing. That is a way to think about nodes. Nodes are kind of like a type of object. They are literally. Godot is an object-oriented language, and there is an object data type. It's more generic than what we're talking about here with nodes, but think about nodes that way. Nodes are instances. Scenes are definitions. In order to instance a scene, you can do it in the editor, right? You can go instance child scene, and I can go game world, and I can make an instance of my scene. You can do that in code too. You don't have to just do it in the editor. Pretty much anything, almost anything you can do in the editor, you can also do in code, just as a cool little tip for you. Let's Godot. So the way that you do that instancing in code, you first have to load the scene. Remember, scenes are resources. Resources are loaded. A resource generally is something that can be saved as a file. And any file in your file system is a resource. Scripts are resources, scenes are resources. Images, music, it's all a resource. In order to have Godot interact with it, you have to load it. With the load function, the Godot's built-in load function, you pass it a string. In my case, I'm giving it a string from this variable, this export variable, game world. When I hit the go button in the main menu, it's going to send a signal that triggers this function, and it then is going to instance. It's going to load the scene, and then it's going to instance the scene. Maybe this will be clearer. This is really what's happening. We load the scene. The scene is a packed scene object. This is a class. Abstraction of a serialized scene. This object has a function called instance that creates a node with whatever scenes node hierarchy, triggers child scene instantiations, triggers node notification instances. So we have the scene here, and then we call the instance method. This creates a node. When you have a node in memory, it doesn't yet know where to put it. It's not in the scene tree yet. To put it in the scene tree, you have to call this add child method. This is the same thing as doing like that, right? Except when you do instance child scene, it first loads the scene, it creates all the nodes, and then it adds them as a child to whatever you right-clicked on in this case. When you do it in code, add child will add it to whatever node you called add child from. So add child Pro tip, control click on a function in the Godot engine to go to the documentation for it. Add child is a function that belongs to the generic node class. This is the base class for all types of nodes. Any kind of node you have, you can add child nodes to it. So in any script, you can always call this, and for any node reference you have. So I have this game world node reference, right? Once I have the game world, I can call add child here and add whatever else other node I want. Sprite new. And that would add a new sprite node to my game world. So when we call this, it's the same thing. These 3 lines here are the same thing as clicking this instance child scene. You can shorten this even further into 1 line if you really are lazy, really know what you're doing, and you don't care about anything. You can shorten it into that. That works too. You can string function calls together. It's fine. But for clarity, I want to do it like this. I want to have a reference to the game world. So I'm creating this game world variable up here so that it's globally scoped for this script. I want to be able to know where this node is later outside of this game starting function to get rid of it. Because when I am done with the game, I'm going to go back to the main menu and I want to get rid of the game world because I don't care about it. So there's 2 ways to do this. I mean, there's more than 2, but I could keep this reference up here, or I could not have a reference up here and just keep it local to this, but then I don't have this reference anymore. So what you could do if you wanted to like not have all these global things is you could make another reference. It's still going to be doing the same. It's going to be referencing the same thing, right? Get node. But this is not great because you can't count on something being named that. Like, this is named game world, and in this case, we're probably only going to ever add 1 instance of it. So this might work, but if this has been freed and we don't have that node there, it's going to crash. But there's no reason for us to have to like make this node and then add it and then forget it exists and then go and try to find it again later, because we can just keep our reference to it here. Oops. We just keep a reference to it globally so that we can interact with it until it's gone, until the node itself is gone. This is just a reference. Like this variable existing doesn't affect whether the data exists in the tree. It just gives us a way to interact with the node. So that's why we do this up here, and that's why we track this here. So let's take a look. So we can watch. When I hit start game, that's where it adds the child. We have instanced and added the child game world. Okay, so why is all that important? So in this game, we have levels, we have worlds, right? So the naive way to put a player in a level is to go into the level scene and make an instance of the player. The problem with this, and the reason that you clicked on this video, is that you have now scoped the player to the level. We don't want that, because we want the player to be able to interact with level 2. We don't just want the player to interact with level 1. What you might be doing is making two instances of the player, putting a player instance in level 1 and putting a player instance in level 2. So you have two players. You don't have one player. There isn't one player with HP 50 and one player, then you pass the data to the other one. You're just making two players. You're getting rid of one player with the level that you're leaving and making another player with the level 2 that you're entering. You don't need to do that because we want the player to be outside of the scope of one level, because the player can go into more than one level, right? So was all that explanation worth it? You understand now? You understand? I hope it helped. So we create a container for all of the stuff in our game called Game World. So our player, since our player is going to interact with more than one level, it is going to be under the Game World scope, and the levels are also going to be under the Game World scope, but lower level, so that if we get rid of a level, we don't lose the player. You want to think about what it means for a player to be in a level in this case, because like you're probably thinking about video games in terms of real world. Like, you know, if you're in the mountains, you're a person, you're in the mountains. So if you have a mountain level and you're a player, your player needs to be in the mountain level. That's not how it works. It's not how it works. The mountain level as a scene, the mountain scene isn't a place where your player has to be in the mountains. The mountain scene says, I have this big pile of rocks and I have a couple trees. And in order for the player to be in the mountains, all it has to be is near big piles of rocks and a bunch of trees, right? So when you instance the mountain scene, what you're telling Godot to do is make a bunch of rock piles and make a bunch of trees. And then your player's already existing in the world, and now they're surrounded by rocks and trees. And so now they're in the mountains. It doesn't matter whether they're scoped within the scope of that doesn't matter. All that matters is everything exists in the scene tree at the same time. So this means when you enter this door, you can just get rid of the mountains and trees, or in this case, the big stretchy Godot face, and you can go to the big stretchy red Godot face. Get rid of the mountains and trees and replace it with oceans and sand, right? So based on everything I've already explained to you, I'm hoping that this should be pretty straightforward, what is actually happening. We're in the game world, right? We start with a player. When the game world starts, when it is added to the scene tree, the ready method runs. You might have like looked at this. Oops. When you create a new script, all this stuff that you probably ignore. Called when the node enters the scene tree for the first time. What does this mean? That means when you call add child. This. When you call add child and you have a node, game world scene instance, that means that adding child calls this ready method. So then when this runs, we do the same thing that we did from the main scene. We take the path to the level scene, the first level we want to start in, and we instance it. Same thing as before, like we were talking about keeping track of a node. We keep track of the current level. We instance it, we add it as a child, then we have to connect some signals. So signals are the way we're going to actually indicate to the game world that we want to change scenes when the player enters the door. So whatever current level we have, we're going to connect these signals to this function and this function. So anytime a room has a door that goes to another room, we're going to call this go to room scene. And it's going to do the same thing, same type of thing. We have instanced, but this is a little different. We're not loading the scene in the go to room method. In this case, we're loading the scene earlier and we're passing the scene that we want to instance into the go to room method. So it's the same type of thing, but instead of doing this load here, we're going to do it before this method gets called. But the same thing. New level, that's a node. Added as a child to the levels. So the exact same type of thing. We're just having the game world instance a level and put it under this. And because we are calling the add child from the levels node rather than from ourselves, it adds it as a child of this levels. And the level itself is very, very simple. It just has those two signals that we connected. And in this case, we are loading the scene that we want to instance up here and passing the scene reference rather than passing a string and then loading it in the world script. And the way these are set up, these transition areas don't even have any scripts applied to them. They're just areas, and they trigger when the player bumps into them. They'll call this transition entered, and this is going to be the player. This is a reference to the player's node. I don't care about it. It doesn't matter. You can do stuff with it if you want, but and then it'll send this. And if we go back to the main menu, we don't need to know where. It's only one main menu, so we don't need to pass anything. In this script, or in this game, I just have one level. So one level only goes to one other level. You can't have 2 or 3 doors that each go to their own level, but we could expand it to do that. Pretty easy. And you know what? Let's do that right now. Let's do that right now. Yeah, let's do it. That'll be good. Because what's this going to do you? This isn't going to do you any good. You want to make more levels, right? You want to make tons and tons of levels everywhere. Okay, let's do it. Okay, so the level script. This level script is shared by all the levels. Each level can go to another single level, but that's no good. We want each door to go to its own level. So what are we going to do here? Well, this is useless to us. So let's not do that. We want to be able to define per door where we're going. So I'm going to make another script. We'll call it transition area. Go watch my naming video if you want to know why I renamed that. Okay. So this is a script that is going to let us tell our transition areas where they want to go. Okay, export var and target. Let's see. Screen. Export var, export string. And there's a reason I'm doing this with a string. Very, very important reason. You might, if you're a little clever Tom, you might realize that we could be doing this. So why aren't we? What are we at, level 2? So we could take this and do this the way we've been doing it. We could also just do this and have that object there. The problem is this can cause a circular reference. Okay, I have to do this. So now I'm in level 1. Let's say we want to attach the script. So I'm in level 1. Let's say for some crazy reason, I wanted the door from level 1 to take me to another level 1. I don't want to make multiple level 1s. It's exactly the same. Circular reference to resource being saved found. When you export like this, Godot has to load the scene, and it has to load all the nodes within the scene, and any global variables also need to get loaded. So what's going to happen here, level 1 loads. level 1 needs to load everything that the nodes load. It loads this transition area, it goes to this scene, it sees this scene or this script. It goes to this script and says, load all this stuff. Oh, there's a packed scene, better load it. Level 1. Oh, gotta load level 1. Make a new level 1. Look through all its scenes. Okay, gotta load this stuff. Okay, gotta load this stuff. Oh, there's level 1. Load it again. Circular reference. Forever. It goes forever. So this will just not load it. It'll just say, circular reference. Nope, can't load that. Oops. This doesn't have that problem. You can reference, I can say, level 1. I'm in level 1, and this door is going to take me back to level 1. It's just going to go to the same level. I'm going to go around in circles forever. That's perfectly fine, because what this is going to do is it's going to clear out our instance, and it's going to make a new instance. So it can clear out the old instance of level 1 and make a new instance of level 1. That's fine. So this is not a problem. So that's why I use strings. You load the resource when you need it. And there's different ways to load. There's different times that it's appropriate to load different things based on your use case, but that's a different topic. So just for now, this is the safest way, I think, personally. And it's a little, you gotta watch out for typos, but you know, it's not a bad trade-off for being safe, in my opinion. Feel free to disagree with me. Okay, so target scene path. But we need to get a way for this to tell this which scene we want to go to. Because I want to keep my scope. I want to keep this area's scope within the level. Because maybe there's more ways than just doors I want to be able to transition. Like maybe I want to transition based on the character dying. The character didn't hit any door, but I still want to transition to a game over screen or something, right? That's just an example. But I still want to be able to go to some other room here. But we need to pass that information from this node up to the level somehow so that the level can then tell the game world where it wants to go. So how do we do that? Let's think about it. I don't have a plan for this. I don't have a plan. We'll just find out. So what do we got to do? Right now we're using this transition entered. So one way we could do it, you can extend the arguments that you send when you emit a signal using the advanced tab. Add extra call argument. This is called a bind. It doesn't really say that here, but in the documentation, if you do this in code, it's called binding arguments. So we can add an extra string argument. And then instead of just sending the body we're going to pass, we're also going to send string. So actually, I'm not even going to use this script. But rather, this is a little bit it's a little bit more hidden, because you got to know to go in here and then you got to actually bind that string as an argument. So what are we in, level 1? So this is the transition area from level 1, and I want it to go to level 2. Transition area, string entered, string, bind, paste, connect, save. Yeah. Let's test it. I don't want to think about this too much. I don't want to like pour over the code and see if it works. Let's just find out. Let's find out if it works. Hey, it works. Sweet. Don't have to overthink things. Okay. So that's our very basic example. We just got it working the same way it was working before, but we no longer have this definition up here. So we now know, okay, per door, we can tell each door which level we want to go to. So now level 2 no longer works because we've also removed that from level 2 because they're using the same script, right? And I don't care about this. I changed my mind on how I want to do this transition area. I don't even care about this. Yeah. Okay, so transition area, And this one's fine because this doesn't, the transition area 2 goes back to the menu, and the menu doesn't need an argument. So we're just going to leave this one like it is. This one, we got to go in here. Okay, we want this one to go back to level 1, right? So get this. Edit, advanced, add string argument, paste, go, connect, save. Make sure it works. Run your code all the time, run it all the time. Don't sit in code for hours and then forget to run and then be concerned later when it doesn't work. It still works. Take damage, go, take more damage, go. Yeah. Nice. And we're going to go back out, make sure that still works. Yay. Okay. So now let's expand. New duplicate. There's a whole other topic on when you want to use duplicate versus inherited. We're going to use duplicate. Okay. Someday I'll tell you when you want to use inherited versus duplicate. Now, this is fine. Transition area 3. So this one's going to go to level 1. This is level 3. Let's make it look different. Change the background color to green. Modulate. Modulate adds, multiplies, I believe, colors on top of whatever sprite you have. I don't remember what the actual functionality for modulating is. Okay, and this one we also want to modulate. I think I was modulating color shape. Oh wait. Am I changing the color? Maybe I'm, yeah, okay. Okay. There we go. Transition area 3. Modulate. I guess this one should be blue because it's going to go back. Okay. This one's going to go to level 2, so we'll make it red because level 2 is red. And transition area 1. It's going to level 1, so we're going to make it blue. Yeah, okay. I'm going to change transition area 3, the text to be, go to level 2. Oops. And we're going to change level 2. Level 2 is no longer going to go to level 1. It's going to go to level 3. 3. That's level 2. Level 3. Position area. This one we want to go to. It's level 1. Is that what we're trying to say? Level 1. This one's going to go to level 2. Let's change that. Edit. That one. Save, connect, save. Okay. Try it. Don't overthink it. Level 2. Level 2. Oh, I forgot to change level 2. Okay. Let's see. We do go to level 3. Uh-oh. What happened? We instantly transfer back. Oh, right, because, okay. Because in these levels, I cleverly arranged the doors so that when you spawn in, you're not overlapping with an existing door. But this one, I didn't do that. So now, as soon as we spawn in, I overlap with that one. So we got to change the doors a little bit. Okay, and level 2 says the wrong thing. So I'm going to say level 3. Oops, 3. And then level 3, let's just move this. And now this is where you get into like, you get into some questions about how do I, like I want the transition area to be in the same place as the player's going to show up. You got to like detect whether the player entered it or whether they entered it for the first or second time. So now we're going back to level 1. We're back in level 1. 2. We're on level 2. We go to 3. Back to 2. Let's test that out. Yes. Level 3. And then we're going to make sure that we can go back from level 3 as well as level 2. Test, 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 test. Sweet. Does that make sense? Will that get you somewhere? Will that help you out? I think that's enough. Come back for the next video. I'll teach you more stuff. You got a lot to learn. Let me just put it that way. You got a lot to learn still. You're learning though. And that's great. You're doing great. I'm proud of you. You're a genius.